let's keep going. So now we want to talk about the magnetic force. So first, opposites attract. So if I said that you got two magnets and you got the north pole of one magnet and you got the north pole of the other magnet, what's going to happen when you try to bring them together? They're going to repel. So opposites attract, and like poles are going to repel. So make sure and know that for the exam. Next thing that you ought to know is, what about wires? So that if you got two wires that are carrying electrical current, then if the two wires are like this, then they're going to attract each other. If the two wires are like this, then they're going to repel each other. I'm not going to ask you to explain why in terms of the right-hand rule. I did that in the videos, but as long as you understand that current-carrying wires are going to either repel or they're going to attract, depending on the direction of the current, that's going to be good enough for the exam. And then what about if one of them has current and then the other one doesn't? What's going to happen? Nothing. So you have to have current in both of them, because a magnetic field can only act on something that is moving. So it has to act on a current. All right, and then I want you to be able to use this formula here, okay, so that the force of magnetism, so this time it's going to be force of magnetism, is going to be equal to charge. So if we go way up here, force of electricity was charge times the electric field. So the magnetic force is charge times the magnetic field, but it also depends on the speed of the charge. And that's because magnetism is caused by moving charges. So if the charge isn't moving, it's not going to feel the magnetism on it. So be able to do a math problem using that formula, and then also be able to predict the direction of the force if you know the direction of the V and the B, and you do that with your right-hand rule, so that your thumb points in the direction of the magnetic force, and then this finger points in the direction of, if it's a particle, it's going to have a velocity. If it's a wire, it's going to have current. And so that's going to be the direction of this one. And then this finger here is going to be the direction of the magnetic field. So there will be a question where you have to calculate the direction of the force, or the direction of the V, or the direction of the B, if I give you the other two. Okay, so you use your right-hand rule for that. All right, so that takes care of that, 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 that. Okay, so now we've got magnetic materials. And so you should be able to tell me what causes magnetism on the atomic level. And so it can be caused by spin. If an electrical charge is spinning, it creates magnetism. It can also be caused by orbit. So if something is in orbit around something else, that also causes magnetism. Notice that in both cases, something is moving. Moving electrical charges make magnetism. But the one that is the most important is the electron spin. As electrons spin inside of an atom, they produce teeny tiny little magnets. And those teeny tiny magnets can add up so that that material can be magnetic. So there are three different kinds of magnetic materials: diamagnetic, paramagnetic, and then ferromagnetic materials. Don't worry about the diamagnetic and the paramagnetic. Not going to be on the exam. But this could make for a good essay question. How can you, what is so special about iron? And then how can you take a piece of iron and turn it into a magnet? And so this gets into the idea of clumps of atoms that are all pointing in the same direction, called the domain. And then when you take that piece of metal and you put it in an external magnetic field, and then you increase the temperature, then those domains will vibrate into position, and then you can turn off the heat and then let it cool down, and then turn off the magnetic field, and then you have a permanent bar magnet when you do that. So that would make for a good essay question, being able to explain that. All right, applications of magnetism. Know what an electromagnet is and how it works. Okay, then we talked about the magnetic field of the Earth. So what causes the magnetic field of the Earth? And then the significance of the magnetic field. So the magnetic field makes a shield that surrounds the Earth, and then that deflects the sun's solar wind. And if that solar wind was to hit the Earth, it would irradiate the Earth, and it would also blow the atmosphere off of the Earth in a few million years. So our magnetic shield helps to protect the Earth from that. But some of that solar wind does get through, and it goes down the magnetic field of the North Pole and the South Pole, and so that's where we get our auroras from. So be able to explain the origin of the Earth's magnetic field. Okay, there's not going to be any questions about MRIs, and there's not going to be any questions about particle accelerators. So that concludes this lesson on magnetism. We've got one more to go. So in our next series of video segments, we're going to talk about electromagnetism.